Category 3, we have domain and range of linear functions, writing linear equations, writing a system, direct variation, parallel and perpendicular lines, linear inequalities, and writing the equation of those. So let's start off with domain and range. So domain and range, domain is the x and range is the y. How do you keep that straight? Well, remember when you're graphing, you do x comma y, and with domain, D comes before the R alphabetically as X does. So domain is the X, range is the Y. Things you will notice when you do domain and range. Sometimes you'll have graphs that look like this. Okay? And they'll say, what is the domain? Okay? Domain is every single X value. So I need to look. Let me find all my X's. So this right here would be -1, -2. This is 1, 2, 3, 4, 5, 6. So where are my values? I've got one here at -2, so I'm just going to list them. One here at -1, one here at 1, one here at 2, one at 3, one at 4, one at 5, and one at 6. So those are all my domains. The range, I'm going to look at the Y values. So maybe there's, I don't know, maybe I didn't do a very good job doing those, but we'll say there's one here at -3, -2, -1. We'll call that 0, 1, and on up like that. So I would list out my range. So this is kind of a rough scale one. So let's just say this is -3, and I'm looking at the Y axis. One at -3, we'll say -2, -1, one right here, this one, right here at 0. Again, the Y value right here would be at 1. The Y value here we'll say is at 3. And there's two of them right there. So, but I only need to list it once. And then 4, 5, and then we'll say it's up here at 5. So, very distinct values. I'm just listing where the points are. Or I'm looking at the ordered pairs and I'm just writing down the domain and range. Sometimes that's easier to do too. The other option is sometimes they're not discrete graphs that I can count. Remember, discrete is countable. Sometimes they are continuous graphs. So let's say that this looks like this. Okay. So this graph goes from here to here. Well, the domain is how wide is it? It's the x-axis. How wide is this? Well, when I look, it comes over here -1, -2. It starts here at -3 and it goes all the way out to right here. 1, 2, 3, 4, 5. It goes every single little point from -3 all the way out to 5. So from -3 to 5, domain is the x and it's every single value. The range. Well, the range, 1, 2, 3, 4, 5. It starts here at 0. Remember, we're looking at the Y. So it starts right here at 0, and it continues up all the way to here to 5. Y is the range, and it always points to the left. So depending on what you have, if you have dots, you're going to list the points. If you have a line, you're going to have those inequalities showing the measurement, the range between all of it. Okay. All right, domain and range. There we go. All right, let me get the next one is, I had it pulled up on my phone, and now it's gone away. There it goes. Write linear equations. Okay, so if I give you that the slope is 1/2, and it goes through the point 2, 1, and I say write the equation of this line. Well, we know that y equals mx plus b. B is the y-intercept. I don't know the y-intercept. So my other option is y minus y1 equals the slope times x minus x1. This is when I know a point and the slope. I know a point and the slope. This I have to know the slope and I have to know the y-intercept, which I don't know. So here we go. So y minus the y1. This is y1, this is x1. So y minus 1 equals the slope times x minus 2. So I could simplify y minus 1. I'm going to distribute. That would be 1/2 x half of negative 2 would be negative 1. I would add 1 to both sides. That would cancel, and I'd get y equals 1/2 x. Negative 1 plus 1 goes away. And I end up with something that looks like this. Now, if I wanted to write the equation of any line out there that was parallel to this, what do you know about parallel lines? Parallel lines. Well, let's see. They look like this, right? They're side by side. Do they ever touch? No, because what's the same? The slant or the slope. So any line that I wanted to write, y equals 1/2 x, all I need to do is just add a little something on the end, plus 2. These two lines are parallel. I could have said y equals 1/2 x minus 10. That would be parallel to that. This part has to be the same. The slopes have to be the same, but the y-intercept is just going to move around. All right, perpendicular lines. So perpendicular lines, that is where you take the slope, which I'm going to use this one still. The slope is 1/2, right? To get the perpendicular slope, and usually what I do is I put a little perpendicular symbol down here. I flip it and switch it. So I flip it and make it 2/1, and I switch it. This is positive, so I make it negative. So what's the equation of a line that's perpendicular to that one? Anything that has negative 2x as its slope. I could say plus 1. I could say just y equals negative 2x. These two lines would be perpendicular because their slopes are flipped and switched. So let me ask you this. If I gave you y equals 2/3 x plus 1 and y equals negative 3/2x minus 10, are those lines parallel? No. The slopes are different. Are they perpendicular? Well, let's see. If I take 2/3 and flip it, I would get 3/2, and it's positive, so I need to make it negative. Flip it and switch it. Oh, yeah, those are the same. So, yeah, these lines would be perpendicular. All right, so the other thing is we got this equation, right? Y equals 1/2 x whenever we wrote that equation. This is a special type of linear equation. When I graph this one, it kind of looks like this. It goes right through here. Lines that go through the origin, we call those direct variation. That just means that y varies directly with x. Y varies with x, okay? It goes through the origin. Usually it looks like y equals ax because the b value, mx plus b, it's just 0. So if it's 0, I don't even have to really write it. It's just this. And these kind of look alike, right? My slope is 1/2. So direct variation, it's proportional. It works that way. Okay, last little bit of this unit, category 3 is, my phone keeps dying on me. Parallel and perpendicular linear inequalities. So yeah, we've already touched on that. So I'm going to go with that as our wrap up. I'm going to, just one more time, y equals mx plus b, slope intercept. Y minus y1 equals the slope times x minus x1. That's point slope. We also have this ax plus by equals c. That is standard form. Sometimes you will get an equation like this. Let's take y equals 2/3 x, we'll say minus 9. And they say put this in standard form, which is like that. Standard form is x and y on the same side, no fractions, and remember that x has to be happy. So, does this have fractions? Yes, it does. To get rid of the fractions, and you may or may not remember this, most of you I think do, you multiply by whatever's on the bottom. Every single thing. So, hippity hop across the top. 3 times y would give me 3y equals 3 times 2/3 would be 2x, and 3 times negative 9 would be negative 27. Okay, no fractions, we've done. X and y on the same side. Well, let me move x over here by subtracting 2x from both sides. So negative 2x plus 3y equals negative 27. Okay, X and Y, check, they're on the same side. Is X happy? Oh, he is not. He is sad. So what I'm going to do is make him a happy X, and I change everybody else's sign. So minus 3y and a positive 27. So from slope-intercept into standard form, remember these key things. All right, I think that pretty well sums up category 3. Good luck on your test.